Welcome to the April 2023 Secure Stage Strategy Review. Today we'll share updates from three product groups: static analysis, dynamic analysis, and composition analysis, which make up the secure stage, along with our vulnerability research team that supports all efforts across SEC. Security is a quite broad market, and in terms of analyst coverage and the other ways of thinking about the market, we actually are covering lots of different areas. So the application security testing, governance, risk compliance, ASOC, you can see that they kind of overlap. There are a lot of different tasks that apply to different roles. We can't solve all of these things, but we do target AST directly. We do target parts of GRC, and we partially play in the ASOC market as well by consolidating the vulnerability data into our platform. So there's some places where we're working today, places where we would consider moving in the future, and places where we're not actually intending to displace entire players. Complicated world, but these different personas, teams, and industry segments are worth knowing so that you can kind of contextualize what we do and what we don't do. So in terms of where we're going to go for this, the ways that we can create value, there's short-term and long-term, always like that. So in the short term, we're really focused on improving SAST, secret detection, the static analysis work, and also the software composition analysis scanning capabilities. They tend to be adopted first, and they're a key criteria for people who are adopting GitLab Ultimate. So they have to work, and they have to show well, and they have to work well. We also need to bring security scan results even earlier into the developer workflow to make that efficiency real. That includes being in the IDE, the integrated development environment, where developers are writing code. In the longer term, we do have to mature our security offering overall. We've gotten by on a lot of open source and kind of bringing things together, providing a sort of platform that's an easier purchasing and operation decision. But we do need to get past that to show risks that are not just vulnerabilities and really helping people prioritize and resolve the most important things first. We also need to innovate. This space is moving very quickly, and we do need to prioritize features that leverage ML, AI, other techniques to enhance the productivity of the developers who are interacting with the results and the security teams who have to manage them across their entire organization with a smaller team. So the secure stage has certain roadmap themes, including simplifying security scanning. As we just talked about, often the scanners are coming in early in an ultimate evaluation, and we need to make sure that it's easy to get them up and running. Making it so that you don't have to think about security. We also have to shift left, no more left than that. So getting testing earlier into the lifecycle makes it cheaper to resolve problems and makes it easier for people to self-remediate. So the more developers are able to look at a finding that is high confidence and correct, resolve it themselves, not even involve security team, we've just won the game here. The more people can spread out the security work across the org, make it everyone's responsibility, the better their organizations will operate and the more value they'll see from Ultimate, and the stickier that workflow becomes. That relates to our security as a team effort, but when security testing is coming in last at the end of a release, it's a nightmare for everyone. The more we can get it shifted left in the process, approachable, the right results, the right number of results, the results that people can act on, the better we are in our ability to deliver a really stunningly good experience. With that, we'll shift into a recent highlights area where we talk about some of the things that have happened, just sort of a roundup of the features across the stage in the last quarter, 6 months or so, and then talk about really where our heads are for the next 3, 6 months, even 12 months. The key features that we'll be pushing on and the key problems we're trying to solve in that time. So recent highlights. I'll start with some static analysis items before passing up to Derek and Sarah, who cover dynamic analysis and composition analysis. So some really exciting things in static analysis. A lot of times when we find a rule is problematic, we want to remove it so that customers don't see it anymore. Or if they disable a rule, it means that they don't want to see it anymore. So now when that happens, we'll actually automatically resolve findings. So the findings that existed before, they're no longer valuable. We've judged they're not valuable. So they get automatically resolved. There's a comment that's left there, and they're no longer require manual triage. We actually use this to resolve the single most positive prone rule in SAST, which we've been waiting a while to remove. waiting for this feature. Now, moving more towards secret detection, making it so you don't have to triage the finding to even get a response. You'll be more secure automatically. We actually now publicly, if you publicly leak a GitLab personal access token project, group access token, that's now automatically revoked. So if you do that in a public repository, we will just catch it and let you know that we got rid of it. That protects you within seconds instead of waiting for you to see it and respond. That response also now covers all branches, not just the default branch. So MRs and branches are protected. As soon as you publicly expose a secret, we are able to respond to that. And in the future, we'll be expanding to more partners. Then we also need better results. So I talked about high confidence results, smoother integration into the workflow. One thing across the whole stage is that all the secure scanners now support MR pipelines. Previously, it was just branch pipelines. This was released a number of releases ago in the latest templates, which are allowed to have breaking changes, and it will be on by default for all stable templates in 16.0 and above. Within static analysis, we also added new SAS rules for better coverage of the languages that we do support, and we integrated proprietary technology to reduce false positives for Go. You'll see in the future direction that we'll also be integrating more proprietary technology to cover up where some of the other open source tools are lacking. I'll now pass to Sarah to talk about the license scanner.
Thanks, Connor. So we recently introduced a new license scanner, and the new method of detecting licenses is integrated with dependency scanning. So they support the same languages and versions, and you no longer are required to run a separate job for license compliance, which results in faster security results and also fewer CI pipeline minutes being consumed. So the results get updated automatically without running another job, and it's capable of identifying over 500 different license types. So our own testing has demonstrated that the results are more complete. And if you look at the two screenshots here, you can see on the left, the previous version, there were a lot of unknown license types being found. And then with the new license scanner, we just have many more results appearing for the exact same dependencies in both of these lists. And then there's also better support for packages that are dual licensed or have multiple different licenses. We've also released a number of other exciting dependency scanning features. So we've released a new variable called DS max depth that allows you to configure the dependency scanning depth. So you can scan your entire repository for lock files. And then we've also added support for npm v3, pnpm, yarn v2, and yarn v3. And I'll pass it over to Derek.
All right, thanks, Sarah. So the thing that we are focusing on here with dynamic analysis is that we released our new proprietary DAST scanner, the browser-based scanner, which runs dynamic analysis from a browser instead of using a proxy to analyze the results. So this actually helps to scan single-page applications and modern JavaScript frameworks. This is something that DAST historically across the board within the market has had issues with. So this will significantly improve our code coverage, our application coverage, as well as reduce the number of false positives that are reported. It also provides a much easier way to debug and configure your scans by providing artifacts like an authentication report, which gives you screenshots of the authentication process so you can see where something might have gone wrong, as well as a crawl graph showing you exactly how we crawled your application and what pages we're scanning in there. It also provides you with a URL output that will tell you exactly what we covered within the scan. All right, moving on to our roadmap plans. First, I need to say that this is looking at upcoming products and functionality and features. So it's very important that this information is used for informational purposes only. Don't rely on this for purchasing or planning purposes. As with everything that we do, things may change. So everything here is subject to a change or delay. it remains at GitLab's sole discretion to change anything about what we're talking about here. All right, so looking first at dynamic analysis, we're really going to be focusing on the browser-based DAST analyzer. So we're going to be continuing to build out our vulnerability library and add new active and passive checks in there, as well as providing pre-built profiles so that if you have a specific application or technology that you're needing to scan, you'll be able to use those profiles to scan that. And we're working on a callback server. And so this will allow for us to better detect and scan for vulnerabilities that require us to either include something from an external site or to call out to an external site to prove that data is being exfiltrated. So we'll be working through multiple vulnerabilities utilizing this callback server. For authentication, we're planning on improving quite a bit, including things like the stay logged in feature for multiple cloud providers, improving logout detection so that we know if the application is logged out during the scan and we need to re-authenticate, doing more with the auth report and the crawl graph, and then making it easier for users to support more customized authentication workflows and MFA to make sure that we support things that are being used in enterprises now. And we'll look at API security next. So with this, we're really looking at API discovery as one of our first focuses. We want to be able to find REST APIs, since we found that one of the big blockers to entry for API security is that a lot of companies don't have a specification or definition that they can use to guide the scan. So we want to be able to do that automatically. So we'll be looking at Java Spring Boot, Python Flask, Python Django, and Ruby on Rails as our first 4 frameworks that we will be focusing on. And then using that, we'll automatically configure the DAST API and API fuzzing scans so that you don't have to build that previously to the scan. Using that output will automatically generate the open API specs for anything that we found, so that you can include that in your repository, not just for the API scans, but just for generic use outside of any scanning jobs. Then we want to be able to analyze APIs better to discover relationships between the API calls, parameter dependencies, so that we can call things like an insert before we delete, or make sure that the data is in the database before we try to call it in a subsequent API call. Also, we want to be able to know the type of data that the API calls are expecting, so that we can more intelligently provide input and make sure that we can let you know when things are not responding the way that you expect them to. And then discover the common workflows and business logic so that we can increase scan coverage and make sure that all the API calls are called in sequence, and that we're testing exactly what you want to test, rather than maybe throwing out the entire API and testing everything there. All right, and with that, I will hand it back over to Sarah.
Thanks, Derek. So continuing with that theme of simplifying security scans that we talked about previously, the composition analysis team is focused heavily on continuous container and dependency scanning. So we've really re-architected both of these features. These are in progress, but once this is complete, you'll be able to identify vulnerabilities as soon as the advisory database is updated without needing to run additional scans, which is a huge benefit for all of our customers. And then rescanning can be done synchronously as soon as new threat data becomes available. And identical findings would be deduplicated automatically. And this is also really going to pave the way for us to add alerting in the future when new critical vulnerabilities are detected. And then we're also working on scanning all images within the GitLab container registry. So we know that there's a lot of pain points our customers currently have where they can't easily scan multiple container images that are built in one pipeline, or can't easily scan container images that are built by other vendors. And this will help solve for that. So we're moving to do this by default so that you don't have to manually run or schedule scans of schedule runs of container scans. And then the findings will appear in a new tab on the vulnerability report page, and a summary will also be shown on the registry page. And it's really going to better empower security teams to get better visibility into potential vulnerabilities in all of your container images. And with that, I'll hand it back to Connor.
Sure, really exciting stuff. So for static analysis, just wanted to cover some of the main themes that we're investing in. And the two sort of high-level summaries here are more efficient triage and smoother day one, day two, and onward operation. So for triage, it's sort of about having better results in the first place. And we have a variety of things we're doing to make sure that the results you're getting are higher confidence and better quality. That includes some proprietary detection technology for SAST in detection mode. Previously, we've used that more for catching false positives from other analyzers. It includes rule improvements, so just making the things we're looking for more specific and more likely to be correct, and better explanations. When we have a result, explaining it better so that people can understand the finding and resolve it better without maybe suspecting that's the false positive because they didn't understand what the finding was. Also, people often have opinions about which rules they want to scan for or which ones don't apply in their context. So today, you can customize rules on a project level. We're adding group level customization, starting with an MVC that's based on CI/CD variables, but looking toward a longer term direction there as well. Currently, all secret detection results are critical. They're at critical severity because, well, a token leak is pretty important. But if we peek past that one level deeper, it's likely that there are things like examples or documentation or tokens that are not active anymore. So really getting past that everything is critical phase will help us help security teams direct their attention better to the things that need to be handled right away versus the things that have maybe been automatically responded to or that are examples. That also improves the ability to use security scan result policies so that you can set up rules for what you really need to know about. And then showing static analysis findings in the MR view, right, and the changes in diff view. That's available for code quality today. And we're adding SAST there so that when you see a SAST result, you can see it with the code instead of having to see it in a widget or a pipeline report and then try to bounce back to the code and see the details out of context. Should really make it easier to understand the results. And then for smoother operation, it's really about being able to configure and operate the scanners more easily. So a really key thing is improving vulnerability tracking. Once a vuln is found, how do we track it so that we're not raising new findings or saying that something's no longer detected when it's really just moved? Especially for secret detection, the current algorithm is using only the line number when really we can use the contents of what's found to make this better. A sort of strategic level push we're making is for a service architecture for secret detection to provide better coverage. So right now you can only scan code bases because it runs in pipelines, but tokens leak other places. A service will help us do this and it'll also help us be on by default without requiring CI/CD pipeline modifications. We have on the docket about 3 times more integration partners for automatic secret detection response. So when we can send the leaks that are public leaks to partners to have them fix them or mitigate the leak, the severity automatically. That means they'll be able to contact the person whose credentials are leaked and sometimes apply technical safeguards to make sure that the account is protected in the meantime. Sometimes they also will automatically revoke the credential. In SAST, we've reduced the number of SAST analyzers over time. We'll continue to do that, centralizing toward a semgrep-based analyzer for languages where this is appropriate and using proprietary technology for others. We're especially targeting those analyzers that require compilation because that's a hard operational experience to try to make sure that the build is completed and that we can run the build instead of just being able to scan the source code directly. And then for code quality, really the focus is on reducing the code climate dependency, removing that dependency because it provides a poor operational experience. We're likely to be able to invest in this type of thing for code quality, but aren't maybe immediately planning proprietary technology for scanning, that type of thing. More of a ability to mix and match the tools that you use to make your workflow more efficient. Now, to just sort of summarize some of the main things that we've talked about in this 12 months, or in this presentation across maybe the next 12 months, you'll see that there's a mix of short, medium, and long-term efforts. I won't necessarily read them all around, but you'll see that we're investing across the categories to improve the experience across continuous scanning for dependency scanning, making it easier to understand SAS findings, just showing them in more places, prioritizing secret detection results better. And then you start to see additional, more, perhaps strategic level investments in better advanced vuln tracking coverage for SAS, cleanups the rule set, scanning of all the container registry images, SAS profiles are another way to manage rule customizations at scale. And then toward the end of this 12-month period, really seeing a lot more of the proprietary things coming in, the tracking SAS findings as they move with a new method or a proprietary analyzer for Golang or other languages. So really exciting set of things that we're looking forward to. I think I can speak for all of the product managers and product groups that we represent, that we're really focused on delivering a quality security experience that helps security teams bring the right results to the right people at the right time. So that's better results, more places, easier to act upon them, and easier to achieve the governance that you need. So really looking forward to the live session where we can discuss any questions that folks have. Please also check out the governance strategy review. They pick up where we leave off in terms of some of the features we're discussing. And we look forward to both learning more and delivering these features. Thanks for coming.